All right, we are now on to section 3, which is on motion and forces. So I want you to think for a second about how can you change the velocity of a soccer ball? What are different things that would cause that ball to accelerate? Because when we say change the velocity, we're really talking about accelerating the soccer ball. Remember, when we think of accelerate, it's positive, negative, or directional. All right, so what basically you are doing is applying a force on the ball. Okay, and a force is a push or a pull that one body exerts on another. Some forces we notice, others are not noticeable. For example, if someone runs into us and pushes us off to the side, we're going to notice that force. However, right now, while you are sitting in your seat, the chair is applying a force on your body. Gravity is applying a force on your body. But you don't really notice those because we have had those for quite some time. Okay. Forces can change velocity. Notice that word can. It doesn't mean that they will, but that they are able to. Two different types of forces that we have, balanced and unbalanced. And then we have net forces, and that is when two or more forces are acting on each other. Think of that as the sum of the forces that are acting on that object. So we have 1, 2, 3, 4 forces acting on an object. We can add all those together and come up with that net force. Let's first talk about balanced forces. Balanced forces are equal in size, but opposite in direction. Because they are balanced, they cause no change in velocity. Okay, so what does that mean again? Change in velocity. We could change that word to acceleration. Okay, so they don't accelerate the ball, so they don't speed it up, they don't slow it down, or they don't cause it to change the direction. That does not mean that the object isn't moving. Okay, so make sure you remember that no change in velocity means no acceleration. Remember that horizontal line on a speed time graph means no acceleration, but it can be moving. Okay, when forces are balanced, the net force is 0. So here we have two kids pushing on a toy truck. One kid is pushing to the left, one kid is pushing to the right. The truck has no change in velocity, so it is not accelerating. So since it started at rest, it is staying at rest. Second type of force is unbalanced forces. Okay, unbalanced forces have two scenarios. They can be unequal in size, or they can be acting in the same direction. In unbalanced forces, when we add them all up, they do not equal 0. So now we have the one kid pushing on the toy car in one direction. There's no force pushing from the right to the left. There's only a force pushing from the left to the right, so that truck is going to move to the right. It's going to accelerate. Unbalanced forces are going to cause us to accelerate. So now I want you to think about what would happen if you push a skateboard with your hand. Is it going to go on forever and ever and ever, or is it eventually going to come to a rest? Is it going to have an acceleration? Okay, that skateboard is going to eventually come to a rest, but what's causing it? Some kind of unbalanced force has to be going on in that system to cause that skateboard to undergo negative acceleration and come to a stop. What is that force? That is the force of friction. Friction is the force that opposes motion, and it is found between any two touching surfaces. So wherever we have two surfaces that are touching, we are going to have friction. And it's going to depend on two things, and only these two things: the kind of surface and the force pushing the surfaces together. Okay? Think of the difference between walking on ice in the winter and walking on a smooth sidewalk. Okay, different surfaces, different amounts of friction. Okay, as well as the force pushing surfaces together. If I apply more downward force on the countertop, it's going to be a lot harder for something to slide over the counter. Whereas with just a little bit of force, it's going to be fairly easy for that object to slide over the counter. So what causes this friction? What's going on that's causing these objects to technically stick together? And what it is it's called microwelds. And microwelds are microscopic bumps on a surface that cause the objects to stick together. Okay. More force pushing makes the microweld stronger, and it means that there's more force to overcome. Okay, we're looking really at a microscopic level here. We are looking at these microscopic little bumps and grooves, okay, that stick together. And as I have a surface, okay, you can see all these little bumps that are sticking together. However, if I apply a lot of force, okay, you can see how these grooves are going to stick together much more. There's now more friction between those two surfaces. Three types of friction that we have: static, sliding, and rolling. So let's take a look at each one of these a little bit closer. First is static friction. Static friction is friction between two surfaces that are not moving past each other. So if two objects are at rest, okay, so what would be an example of static friction? Books sitting on a shelf. You right now sitting in your desk. Two items touching that aren't moving, we've got static friction. Second type of friction is sliding friction. Sliding friction is friction between two surfaces that are sliding past each other. This kind of friction is caused by microwells that are constantly breaking and reforming. Okay, a couple examples for this. Okay, a sled sliding over snow. Okay, you've got your hands sliding past each other as you rub them together. Both of those are examples of sliding friction. Rolling friction is the third type, and that is the friction between a rolling object and the surface that it is on. Okay, think of this as with round objects. This is caused by the microwelds breaking and reforming while the wheel rolls. And examples here are pushing a grocery cart through the store, okay, or your car driving over a road. Okay, each of these types of frictions we'll explore a little bit in the lab this week, and how are they connected and which friction has the most stickiness versus which one is the least sticky. Finally, a topic we need to talk about is air resistance. Air resistance is the force that opposes gravity. Okay, we need to remember or start to think of as gravity as a downward force. So air resistance is an upward force. Okay, so for an object to be experiencing air resistance. It must be falling. Okay, I want you guys to be careful because some of you guys are going to tell me a car driving down a road experiences air resistance. This is not the case. Okay, that's drag. Air resistance is with falling objects. Okay, the amount of air resistance depends on the speed of the object and the surface of the object, the surface area. So speed and surface area. As I increase speed, I increase my air resistance. As I increase surface area, I increase air resistance. Please note, nowhere in here did I say mass affects an object. It's air resistance. Mass has nothing to do with it. We'll talk about why that is more in the next chapter. Okay, so it's air resistance, not mass, which is why feathers, leaves, and pieces of paper fall more slowly than pennies, acorns, and apples. If there was no air resistance, then all objects would fall at the same rate. Don't believe me? We're going to give it a try later. Okay, in lab, you can try it at home. Okay, this is a grocery bag example, but take a piece of paper. Crumple one up, put one to flat out, and drop them. See which one falls the faster. Okay, both pieces of paper weigh the same, so we're taking that out of the equation. Okay, now we have air resistance, so these things fall at different rates. If we want to test our theory of feathers and hammers falling at the same rate, we have to go somewhere where there's no air resistance, okay, which means there can't be any air or atmosphere. So we would have to take it to the moon. Okay. If you want, you can go to YouTube and YouTube this video. It is Neil Armstrong on the moon, and he has a hammer in one hand and a feather in the other, and he drops them at the same time from the same height. What do you think is going to happen? Okay, they end up falling and hitting the surface of the moon at the same rate. One last concept that we need to talk about today, and that's the concept of terminal velocity. Terminal velocity is the highest velocity that a falling object will reach. How do we get to terminal velocity? So the highest speed, it stops accelerating. Okay, the force of air resistance increases with speed. Okay, so as I'm falling, I am going to keep accelerating towards the earth. As I am accelerating towards the earth, air resistance picks up. Eventually, we get to a scenario where the force of air resistance is equal to the force caused by the gravity. Okay, so my first little, we'll say we've got 5 and 2, not balanced yet. Here we're at 6 and we'll go 4. Here we're at 7 and 6. And here we are at 8 and 8. So now in this scenario, our forces are balanced. With balanced forces, remember that we have no acceleration. So at this point in time, this object is going to continue to fall at the same speed. It's not going to pick up any other speed. So whatever that rate is the speed that it is going to continue to fall towards the ground. Okay, the key here is that the faster that air resistance is built up, the lower that terminal velocity is going to be. This really has to do with why we can jump out of an airplane, with a parachute and land safely. Think about what that parachute does. Okay, it's going to increase our surface area. What does increasing our surface area do? It increases our air resistance. Okay, the faster we can build up that air resistance, the lower our terminal velocity. So we're able to fall at a slower rate and land safely. If you have any questions, please let me know. When you're done with this, make sure you get ready for lab tomorrow. Have a great day.